next speaker is Adi Rozenberg. Adi's been very much involved in the development of RIST, and he's going to talk about enhancing SRT with RIST. Adi, take it away.
Okay, thank you very much. To those who don't know me, having been around in the last 4 Vidtranses, my name is Adi Rozenberg. I'm now a founder of AlvaLinks, it's a new company, but I've been around for many years in this industry. Today we're going to talk about how to enhance SRT with RIST. We're going to do a brief introduction to SRT. We're going to talk about what SRT is missing, because everybody here talks RIST, nobody is using SRT, so we want you to get familiar with SRT. I won't make you stand up to say who knows SRT, who's not, but I will make it available for you. We're going to talk about use cases where we want to supplement SRT, and we're going to show diagrams of that, and we're going to show some coding examples that show how do we enhance that. And there is a demo below at the exhibit. There's an SRT over RIST, and this is just this is a live use case that we just demonstrated. So let's start. So why do we want to enhance SRT? So for several years, people have been coming to me talking about RIST, SRT, and they think that it's the same thing because they have S and they have the security and they have the transport in the name. So it's probably the same, but it's not. Many users don't understand what is the difference between SRT and RIST. What is the drawbacks of one or the advantages of the other? I've encountered RFPs and projects that needed to use multiple links, for example, but that was not achievable with SRT. Many SRT users are not aware of RIST. They just hear what is there in the publications, LinkedIn. Haivision does a very marvelous job promoting SRT. There are more than 500 members in the SRT Alliance, and many are jumping on the wagon of SRT, but we want to make them aware of RIST and what the RIST can do for them. Now, functions like multi-link, load-share are very desirable capabilities, but are missing in SRT, and I will touch base on that. Now, back in Vidtrans 2019, I floated the idea of SRT 2.0. The idea was that we will use RTP as the underlying protocol for SRT to make it much more robust. But today it still uses UDT, which is a UDP-based protocol. So the idea came to me because I spoke with customers that wanted the functionality of RIST but could not achieve that with SRT. But the workflow that they used was completely SRT-based. So I had to come with an idea, and I'm not going to change the way you do your workflow. I'm going to change how do I feed your workflow and how do I receive from the workflow. Basically put a wrapper around your workflow to make it friendly and get all the benefits of RIST while using SRT. So I'm not going to talk against SRT. I'm not going to be biased. So let's do an introduction to SRT. SRT stands for Secure Reliable Transport. It's an open source published in 2017, maintained by Haivision and community. Now, this presentation was made 2 weeks back, and the last stable version was 1.44. But as of this morning, we have 1.5 that I personally was waiting for that for almost 2 years. I actually asked yesterday to publish that 1.5 and was so happy that wake up in the morning and I got an email, hey, you have 1.5. Well, I don't need my presentation anymore. And I will explain what 1.5 brought to the industry. So SRT gained a lot of popularity, replacing many proprietary reliable delivery solutions, mostly focusing on RTMP and ZigZag replacement. There is existing a demo application that you can download. It takes a few minutes to an hour to make it run, and it gives you very nice capabilities. It is not intended for production. You basically get the code afterwards, and you play with the code, and you make it work. And the capabilities that you can get, you have a listener, which is a server side that you basically do a call home to. You have a caller that dials into the server, so it establishes a connection. There is something called the rendezvous point where two peers can join in the middle. It is UDP protocol based on UDT. It's mainly for point-to-point applications, but there's also an SRT server application as an open source called SLS, and it gives you a multi-point and multi-point-to-point application, which is very nice. And I found that many users are using that, and it's very cool applications that I used myself. At 1.44, there was an experimental 70/2022-7 with 2 paths. And as of this morning, the experimental is gone, so it's active. And there's also what was an experimental active failover mode. You have one active signal and one backup, and if the active goes down, it automatically switches to the failover. So it's a very cool application. And as I said, I've been waiting for 2 years for version 1.5 to become live, and it happened this morning, so there you go. So let's understand what SRT does. It's an open source. As I said, there's a server-client architecture. It's regardless of the functionality, whether you're sending data or receiving data, a client will call home to a listener, which is the server, and by that way, it will traverse its own NAT firewall. But on the server side, on the listener, you still need to open ports so that the data can pass to the server, to the listener. Each side can be a sender or a receiver. Each thing can be of one function, whether to send or to receive. I have seen applications that doing both on the same link, but it's not that documented. It is secure and encrypted, unidirectional connection. You can do a passphrase word and encrypt that at 16, 24, and 32 bits, which is quite nice. It has auto-configuration options between the 2 endpoints to optimize the buffers. So how do we enhance the SRT? So here is an example. What we do we have a pointer? So basically, this is an SRT flow. In this example, this is a server, which would be at the transmitter, and this is a receiver. So you leave your flow. The only thing you need to change is to put in RIST to drive the data through the SRT, and the SRT will take that data and pass it through. So all the protection, all the encryption is done by the SRT, so you don't change your workflow. So IT people are very happy. On the receiving end, the SRT will hand off that data to the RIST receiver, and then it will flow out as much as you want. So in this example, we are going to use a libSRT. My apologies. libSRT is the transport protocol. It is agnostic. It is not protocol picky. Any UDP, CMAF, or content, or whatever you want to feed it, it will take it and push it to the other side on a timely manner and output that as it came in. Incoming packets are timestamped for constant delay output on the receiver side. We can push RIST, which is UDP RTP based, to be carried as a payload to the other end. And we will allow SRT to provide the error recovery and the delivery for us. RIST will only provide the stream component separation and aggregation parts. Well, that sounds boring. So let's see that in action. So in this example, that many found very interesting in the application, we are showing one of the kicks of the RIST capabilities, the ability to do seamless switching, 70/20/22-7. But you don't have to contain yourself to 2 paths. You can do 3, 4, 5, whatever you want, depending on the implementation. So in this example, we have a stream coming in. We'll take a RIST element. Later on, it will be a libRIST, as an example. And we will create 3 duplicates. Each duplicate will feed an SRT, and the SRT here, and it will hand off the stream to a libRIST receiver. So if one goes down, the other 2 are active. A second goes down, the third is active. And this is something that was missing in the SRT tool set until this morning. But even today, I think it's only applicable to 2 links. And with SRT, you can increase that. With RIST, you can increase that, sorry. Now let's go further. Let's do loacher. What is loacher? Just like with cellular bonding, instead of sending a full copy, we will split the stream among multiple paths, whether a full copy or a partial part of the stream, and we will deliver that. Once again, the SRT is not picky. We take the RIST, we take the stream, and we divide that, in this example, 45, 45, and 10. The SRT is not picky in the sense of waiting for the entire stream. Whatever comes into me, I will just push that out to the other end. So I will have 45 here, and 10. Those will be fed to a RIST receiver that will re-aggregate that, dejitter that with a very small dejitter buffer, because most of the dejittering is done by the SRT, so the added latency is very small. And you have improved SRT with loacher capability that many people wrote articles, testimonials, that it is missing, and now we just advance SRT forward. Another nice feature of RIST is null packet deletion. Advanced main profile, RIST main profile gave us the ability to reduce the null packets while in flight. This is something which is missing in SRT. So I said to myself, why not to do that? So once again, we take a RIST device, push the stream in, drop the null packets, feed those to the SRT, it carries that to the other end, come to the RIST, and the RIST receiver will inflate back and insert the null packets. So we brought that capability to SRT users right now. They can benefit from that. Basically, cahooting together. Another capability, which is not available in open products, but it's something that I did in a past position, is the use of deferred protection. What is deferred protection? It means that I'm sending my data unprotected over one link, and the protection is done over a different link, like 4G, 3G, whatever, open internet. And by this method, you save bandwidth on your expensive link. So if I need to carry 80 megabits, I will pay only for 80 megabits, and the protection I would use an open internet. So in fact, I'm saving money. So again, a RIST device will split the stream and push it to the SRT. That will be pushed forward, but the protection will go on a different path, and the RIST receiver will be able to re-aggregate and provide protection on that stream if the SRT is not adequate enough to do that. Another idea that people asked me was that we always said that security with RIST is better than SRT, because SRT is a pre-shared key, PSK based. So why not to use RIST Tunnel to improve the security of SRT? So simply put, we change positions. This is the first time we change positions. We have RIST main profile, DTLS based tunnel, and now we just carry SRT packets through. All the protection is provided by the SRT. This is the first time we change the workflow, just to provide DTLS, certification-based, rotation-based encryption and certification, and provide it to SRT. Well, let's see an example how. So this is good. So some code. People like code. So let's understand. So on top, we have the sender. In this example, we're going to use seamless switching. And what we are doing is I use the lib-RIST as the sender. I use the SRT Live Transmit as the application for the SRT. So we have the sender, we have the server side, the receiver side, and we have the RIST receiver. There will be a diagram afterwards. So let's understand what we did. We took an input stream, and we created two duplicates, two multicasts. 2 to 5, 5, 5, 5, 5,000, 2 to 6, 6, 6, 6, 6,000. Those are internal. And I feed them to a SRT. So here's the 5,000 port, just for ease of use. Basic configuration, just a listener. I didn't go to multiple options. The only thing that you need to see is this part. This is to allow it to carry RTP packets. Because out of the box, SRT is optimized to standard UDP packets and not RTP. And this is the second path. And on the receiver side, we tuned to this link, and we output a UDP stream on port 5,000 and 6,000, and those are fed to the RIST receiver, 5,000, 6,000, and it output it. Well, let's see the diagram. It's easier to understand. We have the stream coming in. The libRIST splits that to two duplicates, feeds that to the SRT. This is the client receiving that, pushing out the 5,000 to a libRIST, and the other side, the other part, the same thing, and we have the stream out. Okay? So let's spice it up slightly more. So this is the 100, this is the 7020.22.7. So now we want to do something much more exciting, and this is actually the demo that runs in the exhibit hall. So once again, the only changes are very subtle. On the RIST sender, what I'm doing is just adding weight. When I do it this way, I'm splitting that 30, 3 to 7 or 30 to 70 ratio. And I'm using exactly the same configuration, just like in the previous setup, to a RIST receiver. So you can see it here. So now we have 30% going on the, through ISP-A, 70% over ISP-B. We didn't change anything in the SRT. The only function, and the libRIST receiver doesn't care. It will just take that. This is an example of null packet deletion. All you need to do is add a small n to do null packet deletion. Everything else stays on the same, and you get null packet deletion. That's it. I hope it was very short. Yeah, questions?
Go ahead, Mike.
I was just curious, watching the presentation, it appeared that RIST adds a lot of value to SRT, but my question is, does SRT add any value? Do you really need it? Or can RIST do everything that SRT can do?
I don't want to be biased for RIST because I'm a member of the activity group, wasting 2 hours of my time every week and a third one every 2 weeks.
Okay, you can be biased.
Yeah. But I also, on the other hand, there are much more users of SRT in the world. This use case came to me when I met the Chinese guys. I met the Chinese market, and the entire Chinese market was SRT based. So I can go and try to explain to them RIST. They didn't know what is RIST. So that was the way for me to explain to them, hey, you are missing this functionality. They went to SRT and checked it, well, it is missing. And I needed a way to let them know what to do and how to do that. I do believe that the RIST Advanced Profile is an amazing technology that can carry on everything, starting from compressed to NDI to JPEG XS to 2110. That is an amazing technology that I believe the industry should embrace, and that should fuel the industry for the next 10 years. If we want to take CMAF, there's no problem. They just take the CMAF, the question that I had to the previous presenter. Take the CMAF, the RIST Advanced Profile is natively can support that. It will take TCP, whatever content, and will push that. RIST was made by professional for professionals. SRT is targeting more for the consumer. It's easier to operate. It takes less time to understand how it works, and it works in 80% of use cases. It will work and it will perform. Now, if you don't need SMPTE 2022-7 and you are happy with what you have, hey, there are many Twitch users that are using SRT to do Twitch for e-gaming. I cannot go against them. I would want to educate them that they have the option to select LibRIST because it's more professional. But I don't want to be biased in that sense. I can tell you that I have deployed multiple SRT implementation carrying tier 1 content, and it worked fine. And when there was a problem, usually when they didn't say the protocol is bad, they said my network is bad. Most users don't know that. Any other questions? Now, to those who want to learn more about LibRIST, go to Sergio. To those who want to learn about SRT, we have Gislen here from High Vision. I'm pretty sure that he will be happy to answer questions. Yes?
Yeah, in one of the slides you showed where you had a protected path and then you had your redundancy or you went through a non-protected path.
Yeah.
How do you deal with the delay between those two paths when you're trying to resolve it at the other end? Because it seems to me the delay would be significant.
Good question. But stay there. No. In this application, the second path only carried protection data, only the error queue. So the application is that you save money. If you don't want to pay, let's say you want to carry an 80 megabit stream. Usually, you will go to your network operator and you say, I need 100 megabits because I need some headroom for the ARQ. Let's say you need like 10 or 15%. The application there, you save money. You say to them, I want to carry 80 megabits, I want to pay for 80 megabits. The recovery, the protection, is carried over a different link. Now, how do you care about that? How do you compensate that? You have a buffer. The jitter buffer that you have in the RIST should be configured to compensate for that.
Okay, it just seemed to me like a lot of delay, but yeah, okay, thank you.
Thank you, guys. It was a pleasure.